Okay, so we can now use the integration to move from acceleration to velocity and from velocity to displacement. Then it tells you about the plus c. It's the constant of integration is determined by the initial state of the particle. So in the kinematics, we must get told if we're going to. The questions will involve actually finding out what this plus c is. And to do that, we're going to need to use information from the question, which will be provided, initial conditions we'll call them, that will allow us to work out C. So this example, a particle is moving on the x-axis. Remember, this is one-dimensional kinematics, so we're going in the positive or negative direction. And at t is 0, the particle is at the point where x equals 5. So there's your initial conditions. We know that at t is 0, x is 5. It's like knowing a point, like a coordinate, a set of coordinates that works. The particle is at the point where, oh flipping heck, just read that. The velocity of the particle at time t seconds is 6t take t squared meters per second. Find an expression for displacement from O at the time t seconds. So that's going to be a general equation that links time to displacement. And so we have been given an equation for velocity. So to get to displacement, we can integrate the expression for the velocity. And so because we're sort of thinking, well, that expression for displacement to get to velocity, to get to this equation for velocity, must have been differentiated. So we're allowed to reverse that by integrating to get back to it. It's kind of like, sort of like a trick. So x, they want us to use x. So I've done this in a lot more steps. Well, not a lot more, but more steps than I necessarily would do all the time. Because once you get good at this, you'll just sort of write it out. So I've got 6t take t squared, add 1 to the power, which is currently 1, and then divide by the 2, the new power. I've got t squared, so add 1 to the power, divide by the new power, and then this adds c. So my general equation for displacement is x equals 3t squared take a third t cubed add c. Now in this particular example, we are told that displacement is 5 at t is 0. So I can substitute x is 5 and t is 0, like here, to find out what c is in this particular instance for this particular particle moving on the axis with velocity here as it stands. So I find out that c is 5, and so my expression for displacement is in a more specific sense for this question is x equals 3t squared take a third t cubed add 5. Part B, find the x coordinate of the particle when t equals 6. All right, we'll take our equation. At t is 6, x equals, and we'll substitute 6 in, and it's 41 meters. That's from the origin. Okay, so it's with respect to the fixed origin. Now I've added a question C. Find the distance from the start point. That should say at t is 6. So we've just found its displacement from O at t is 6, which is 41 meters from the origin. The distance from the start point at t equals 6. Well, the start point was 5, x was 5 at t is 0. And so this further displacement is the difference between them, and that's 36 meters. All right. There's a lot of notes, actually. You probably prefer to do the activities than listen to this. Okay, so this page introduces something called definite integration. So it kind of walks you through it in this question, and then introduces the notation for it here. So just ignore that for a moment, but look at this. So a particle travels in a straight line. After t seconds, its velocity v is given by the equation here. Find the distance travelled by the particle in the third second of its motion. So first of all, we've been given velocity and we're being asked about distance, so that's going to involve integrating velocity to get our expression for displacement. And that will be general in the first instance because we've got a plus c. Now, we don't get any initial conditions to establish what c is, which is an issue, except for the fact that with the question is of a particular type. It says, find the distance travelled by the particle in the third second of its motion. So the first second of its motion is between 0 and 1 seconds. The second second of its motion is between 1 and 2 seconds, and the third is between 2 and 3 seconds. So I need to be clever and think, well, the distance travelled in that interval, 2 to 3 seconds, will be its displacement at 3 seconds, take away its displacement at 2 seconds. So what I need to do is substitute t is 2 and 3, t is 2 and t is 3 into the general solution. Okay, so I've written that out. So find difference between displacements at t equals 3 and t equals 2, and it won't matter that, and so this is the important part. If we substitute t is 2 and t is 3 into the equation, we've still got our displacements with a c in. 2 add c, minus 12 add c. Remember the negative and positive, it's just about the direction from the start point. So displacement has a direction as well. Now, ordinarily, if the question wasn't the way it is, it might be an issue that we don't get any initial conditions or that we don't know c. And so find the difference. So if we find the difference between those displacements, those are our expressions for the displacement, so those two times. It won't matter that we have no initial conditions. The c's will cancel, the plus c's will cancel when we do the difference between. So the difference between minus 12 add c minus, bracket, remember brackets, 2 add c, and that gives us minus 14 meters displacement, and so distance equals 14 meters. Remember, distance, you take the absolute value. Displacement can factor in direction as well. Right, so the next part just gives you a more formal process for answering a question like this. So in the example above, when we worked out the displacement between two given times, the constant of integration cancelled itself out. The times 2 and 3 are known as the limits, and so that's actually right important. This notation, this terminology. 2 and 3 are the limits, and we call this kind of calculation definite integration. It has its own notation and method illustrated in the example below. Since a displacement, this is where it all ties in nicely for this topic. Displacement, you know, is the area underneath the curve of a velocity time graph. Okay, so displacement is the area under the graph of velocity against time. We can interpret a definite integral as an area. So when we get into sort of general application of integration, when we get away from the kinematics after we've finished with that, the integration that we're doing will, in some examples, pertain to areas underneath curves and between the x-axis and the curves. So same question, correct notation for this problem. So you would set it up as an integration, and before we didn't have these numbers here, we would just, and if the numbers weren't there, it would just be saying integrate that with respect to t. Well, because of these numbers here, it's asking us to do a more specific thing. We're going to integrate that with respect to t, but it's the notation is instructing us to do what we did here and substitute in t is 3 and t is 2 to our answer and find the difference between them. So we've got 5. Oh, by the way, here with the 5 the 5 integrates to 5t because of the rule. 5t 5 you could think of as being 5t to the power of 0. Well then, because that would be 1 and it would just be 5 still. If we add 1 to that power and we divide by the 1, then it would be 5t to the 1, like we have here. So that was that. So then this one, same thing, we've got 5t take t cubed, and then you need these once you go from being asked to integrate a function with limits to integrating the function and getting an answer for that with the limits, then the funny s and the dt comes to box brackets with the limits on this side, upper and lower. The next stage, and you do need to write this out for the marks because you just do, you write out the first box bracket with the first limit, with the upper limit substituted in, then take away box bracket, lower limit substituted in. The rest can be done in your calculator. You don't necessarily have to go and work out what that is, then work out what that is. If you're competent with your brackets on your calculator, you can shove all that in and get the right answer. What I would suggest is doing it in stages, that, and then just finding the difference. The brackets are incredibly important because you can get in a mess. And what do you know? We've got minus 14 when we do it like that as well, relative to the origin. And what was it asking for? As an area, well, the area between a curve, even if it's below the axis, is an absolute value and it equates to distance. So we wouldn't have a negative area, would we? So 14 meters. There you go. I think I'll call it there again because I've got a little bit more to do, but don't want the video to be too long.